Welcome back to the deep dive. Today we're getting into a really interesting engineering problem. We're looking at the specs for the PureLink HOF T2.0, which is a 4K HDMI over fiber extension system. And our mission really is to figure out how you send a perfect top-tier video signal, not just across a room, but, well, across miles.
Right. And the thing that just immediately jumps out at you is the scale we're talking about here. This system can move video, audio, and all your control signals up to 1.24 miles.
Wow.
That's 2,000 meters over a single fiber optic cable. This isn't your standard HDMI extender. It completely changes how you can design a large venue or campus.
Okay, so that distance is the first huge hurdle. When you're pushing that much data, 18 gigabits per second, that far, signal integrity has to be the #1 concern. What kind of quality are they actually guaranteeing at the other end?
They're guaranteeing the absolute highest fidelity. We're talking full 4K resolution at 60 hertz.
Okay.
And critically, with 4.4.4 color depth and HDR. That 18 GBPs breaks down to 6 gigs per color channel.
So you're not losing any color information.
None. It means you've got solid HDMI 2.0 and HDCP 2.2 compliance from end to end. It's future-proof.
So that brings us to the core choice here, the fiber. Why is that the magic bullet for this distance problem? Why light instead of copper?
Well, think about it. A copper cable that's over a mile long, it's basically a giant antenna.
Right.
It's going to pick up any and all electromagnetic interference. EMI from cell phones, police radios, you name it. It scrambles the signal. But fiber uses light. It is completely impervious to all that electrical noise.
So it's a silent medium.
Exactly.
Yeah.
You get lossless transport, which is just absolutely essential for these high-bandwidth signals over long runs.
Okay, so the visual is pristine, but what about the sound? In a high-end setup, bad audio can ruin the whole experience.
It handles it perfectly. The bandwidth is so high that you can send uncompressed audio, like LBCM 7.1. But it also handles all the immersive formats. Dolby, True HD, Dolby Atmos,
DTSX.
DTSX, HDTV, Master Audio, all of them. You're not compressing anything or losing quality just because of the distance.
Let's shift to operational control, because in a pro setting, you need to do more than just see a picture. You need to manage the device.
Yep, and it carries control signals right alongside the AV. You get bidirectional IR for your basic remote control functions. And for professional use, you get RS-232 control.
At what speed?
It's running full duplex at a really fast 115,200 bits per second. So a building management system can talk to the source and get a response.
And I see it has KVM support, keyboard, video, and mouse. Now, with a mile of cable, is there a noticeable latency issue with the USB extension? Is it actually practical for, say, a fast-paced control room?
That's a great question. Ultra-low latency is always the challenge over that kind of distance. But its inclusion here is about extending a workstation. So think of an engineer in a stadium press box controlling a server a mile away.
Got it.
It's definitely fast enough for critical operational management, even if it's not for, millisecond fast gaming.
I want to go back to something you said about system intelligence. The spec sheet mentions real-time auto-EDID management. Why is that automatic handshake so important in a big installation?
EDID is basically the source telling the display, here's what I can do. If that negotiation fails, you just get a black screen.
A technician's nightmare.
Oh, absolutely.
Yeah.
So auto-EDID simplifies that whole process constantly. It prevents those headaches, especially if you're swapping sources around. It just works.
And one last detail here that really screams professional. TAA compliance.
Right. The TAA flag means it's Trade Agreements Act compliant. That's a key requirement for U.S. government procurement. It signals that this gear is built for high security, defense, or critical infrastructure projects. It's not just for commercial use. So if you tie this all together, the big takeaway is that distance really isn't a barrier anymore for pristine 4K HDR quality. The combination of fiber and smart system design just completely defeats electrical interference.
So, thinking about the future then. If we can maintain a perfect 18 GBPs video signal over more than a mile, what does that tell you about the future limitations, or maybe the lack of limitations, for data distribution inside a huge university campus or a citywide entertainment district? Something for you to think about until our next deep dive.